determinant of A. Okay, so we're just going to replace this inverse with the adjoint Okay, so I think we talked a little bit about this before, but we're going to split this up into what we call strictly proper response to the transfer function and sort of an instantaneous response. And notice that the instantaneous response is just the D matrix. And notice that my output in the state space representation is some form of my state plus some form of my input. So if the output is just some weighted portion of the input, we call that the instantaneous response. Okay, and then there's like a state response as well. So a system response, instantaneous response, and that corresponds to a strictly proper matrix, and then this other instantaneous thing. Okay, so we're going to divide our transfer function into some numerator over some denominator. My denominator is just going to be some polynomial, okay, of degree R. Okay, so if I have a strictly proper matrix, that means that the order of my denominator is greater than, strictly greater than the order of my numerator. numerator. So I know if I have a polynomial of order r, that my numerator is going to be of order r minus 1. Okay, so the order of the numerator is always going to be strictly less than the order of the denominator. Okay, so that's, sorry, a lot of writing. But the idea here is that if I get a transfer function, now, let me step back. We first said we have our A, B, C, and D matrices, and we can go ahead and we can just determine a transfer function, right? This black, right? So now what we're going to try to do is we're going to try to find a way to go the inverse. So if I have a transfer function, if I can get it into this form of some matrix numerator over a common denominator, right? This thing's not a matrix, it's just a polynomial. Then I can just immediately roll out a state space representation that's already somewhat diagonalized in a companion form that's like transposed. Keeping in mind that we have this instantaneous response right here. So if I have any generic transfer function, I can create a strictly proper matrix and then an instantaneous response. I take a strictly proper matrix, I go through this mess, and I can immediately get a state space response. Okay? So now we got to figure out how this can be. So this is just a claim. Now we're going to try to prove this. Okay, so I'm just going to define some matrix Z that's going to be equal to this whole part. Okay, SI minus A inverse times B. Okay, so if I just take that definition and I just solve basically for S times Z, I'll get this guy right here. And then I can write it out long form by putting in my definitions for my A and B matrices, which are right here. Okay, so I've basically just taken this equation and filled in the A and B matrices in here. Okay? And then we can see a few things. So let me do this. Okay, so S times Z1 is just going to be this row times that column plus this guy, okay? Okay, everybody get that from that? Just this first row. I'm going to multiply this whole top row times that, and then I'll get that. Everybody follow that thus far? Okay.
Please, keep talking.
All right. Here I got s times z2 is equal to z1. Everybody see that? This is from the second row. S times z2 is equal to z1, and then there's a 0. If I go down to the third line, I want to get s times z3 is going to equal to z2 because this thing's all diagonal. And so if I replace, solve for z2, I get z1 over s, and I get that. Okay, so what I can do in general, we can do another one here. So what we can say is that okay, so for any of these z's, I can replace it with some function of z to the first. Okay? Is that any of your guys' cell phone, or is that?
That's all.
Huh?
I think Bradley Phones uses that for his one.
Okay, so I can replace all of my z's with this function, and we can get okay, so now I've just rewritten this equation, knowing what I know now about the relationship between each of these matrix parts, and now we've got z1 in terms of z1. And notice that this polynomial is getting very close to my original polynomial. Okay, so just solving, we found that everything is related to that original z to the 1. And if I multiply that by my polynomial, Okay, so if I go ahead and know what I know, I can solve for Z1, and I know what Z2 is in relation to Z1, and we can get each of these definitions for Z. Okay, so this was just my definition of my transfer function. I've got my strictly proper matrix plus my instantaneous response. I can replace and insert Z. And we know what Z's form is right now. It's that. Okay, so this becomes